In this lecture, we will discuss about the memory, computer memory. First, we start with the basic definitions for the memory. They are listed here, as you can see. The memory itself is a collection of storage elements, storage cells, together with the necessary circuits to transfer information to and from them. So our final aim is to transfer information to and from the storage elements. And once we put all the storage elements together and prepare basic circuitry, necessary circuitry in order to do this kind of transferring of data and the storing of data in those storage elements, we will have the memory. The next definition is regarding the memory organization. The memory organization is the basic architectural structure of a memory in terms of how data is accessed. For example, how many elements are we going to put besides each other? What will be the size of each element? Are we going to have 8 bits for each memory element? Or are we going to have 4 bits for a word, for example? Then we have the random access memory, or RAM. It's a specific kind of memory which is organized such that data can be transferred to or from any cell in a time that is not dependent upon the particular cell selected. So basically we have two ways of transferring data in this case. We can read from the memory and we can write into memory into any cell independent of the, in terms of time, independent of the cell which is selected. And then the next definition is regarding the memory address. The memory address is a vector of bits which identifies a particular memory element. So once we have a given number of storage cells together, when we want to write into them or when we want to read from them, we need to be able to point to one cell, to one of the cells. For that, we need to use a vector of bits which is called as the memory address. You can see an example of a memory here. So we have memory elements. These are the memory elements. You can see that each one, the content of the elements are shown as well. So I'm highlighting a couple of them such that you have a look at them. So each word here has 8 bits. And in order to refer to any of them, we are using these memory addresses. A unique address is determined for each word, so by using that address we can directly point to that word. Here we have some more definitions. In terms of data elements, basically we can have a data element in the form of a single bit, which is a single binary digit. We can have it in the form of a byte, which is a collection of 8 bits accessed together, or we can have a word which is a collection of binary bits whose size is a typical unit of access for the memory. We can have words of the size 1 byte, 2 bytes, 4 bytes, 8 bytes, and so on and so forth. The memory data is the information that we want to write into the memory or the information that we want to get to read from the memory itself. So it could be written into or it could be read from the memory. And then we have the memory operations. These are the operations which are going to be performed on memory data, which are supported by the memory unit. And typically they are the read from memory and write into memory operations over some data element. For example, we can do it for a single bit, a byte, a word, and so on and so forth. In terms of memory organization, as we already mentioned, for the memory we have a given number of the memory elements besides each other to which we can refer using an address, memory address. So basically we have an indexed array of words. So we can say word number 0, 1, 2, 3, and so on and so forth. We have an index in order to refer to them, and this index is indeed the memory address. You can see the addresses here. You can say that we have indexes here. For example, we have index 0, 1, 2, 3, 4, and so on and so forth. How the elements are put beside each other in terms of their size as well. So what's the width of the elements? How many elements are we going to put beside each other determines the memory organization, and it is usually done in a way that it fits the needs of a particular computer architecture. So whether we have two bytes for a word, 4 bytes, 8 bytes, and so on and so forth, it's done in a way that it fits the needs of a particular computer architecture. Here you can see examples. For Digital Equipment Corporation, PDP-8, they used a 12-bit address in order to address 4096 of 12-bit words. So each word that they have over here, it contains 12 bits, and they had in total 4096 words in their memory, and in order to address them, they used a 12-bit address line. In the other example, for IBM 360, they used 24-bit address, so they will have more memory elements compared to the previous case. With this, they could address a given number of 8-bit bytes or 32-bit words, which basically is 4 bytes. And then in the next example, in Intel 8080, they use 16-bit address line in order to address 65,536 8-bit bytes. So you can see that the memories could be constructed in different organizations. Here we have the block diagram of the memory. We have the memory unit here. The number of the words is 2 to the power of k, and in order to access them, we are using k address lines. So here we have the address input, and for the address input you can see that we have k number of elements, and then for each word we have n bits of data. So the elements that we have inside the memory, and they are put beside each other like this, each one has n number of bits, and therefore the data lines, the data input line and the data output lines that you can see here with the directed arrows, each one of them will also have n number of elements for the line. Okay, so n data output lines and data input lines. They should be the same as the number of elements in the number of bits in the memory elements. And then we have one read signal, which is in the form of a single bit, and one write signal, which is in the form of a single bit as well, and they are inputs to our memory. So when read is equal to 1, we can say that we are going to read from the memory, and therefore some information from one, let's say, memory element, which is determined by the address over here, will be provided at the output of the memory. But while we want to write into the memory, write command here will be equal to 1, and then the data which we have at the input side of the memory will be written into some memory element, which is determined again by the k address lines. So we can read from the memory and we can write into the memory. To determine which element we are working with, we need to use the address lines, and then with the data lines, we determine which data we are writing into the memory, or we can take the data out of the memory. Here you can see an example of a memory organization. The memory content is shown in the right half of the table. So by looking at it, we can see that for each element we have 8 number of bits, 8 bits per element, and in total we have 1, 2, 3, 4, 5, 6, 7, 8 words. This is the size of our memory. We have 8 words, and for each word we have 8 number of the bits. In order to access these 8 words, we need to use 3 address lines. The 3 address lines will be in this form, so we can go from 000 up to 111, and here you can see the decimal address as well. And with these values, we can refer to any of these elements, and then we can write into that element or read the data from that element. So with 3 address lines, we can address 2 to the power of 3 or 8 number of words, and in this case our words have 8 bits of data.